Welcome back to Systems Analysis and Design. And what we're looking at today is Object-Oriented Analysis. And it's something we have talked about before, but we're going to go into it in much more detail today. So I think you might recall at the start of this section on Systems Analysis and Design, I showed you these key terms. And really these are the, 10 or 12 things that you would really want to get done if you were going to be a systems analyst and designer. And from these, you can see I've highlighted 3 in green. And those 3 are the ones that we're going to get covered at the undergraduate level here. And they are the foundation, the bedrock of what needs to get done. And so we're going to make sure you understand how to do class diagrams, unified modeling language, and use case. Now those are not in order actually. Unified modeling language is the kind of overarching language we're going to use. Then we'll jump next into use cases. We'll do use case diagrams, use case narratives, and then we'll move on to class diagrams at the end. So this slide is actually in reverse order. But nonetheless, what I want to show you is this picture here. And this picture here shows you all the different unified modeling language diagrams that you could do. And if you were a specialist in the unified modeling language, you would know each and every one of these. I don't know even how many there are. But nonetheless, take a look at this picture. You've got a diagram at the top, and you can see that it splits into 2 halves, structural and behavioral diagrams. And you can also see that I've kind of highlighted 2 different pieces, there's 2 circles, 2 ovals in red. One is under the structural diagram and one is under the behavioral diagram. And under the structural diagram, you can see that I've highlighted object and class. And that's what we're going to focus on under structural. And under behavioral, you can see that I've got use case. So let's move on and let's discuss what the heck the difference is between structural and behavioral, although I think it's kind of a little bit obvious. Structure talks to the structure of how we're going to build things, and behavior speaks to how a user or anyone else, it's kind of the logic that goes behind things. So the structure, how you set things up, and then behavior is the logic that goes behind things, just at a high level. But let's move on. So structural diagrams, kind of these answer the question, what's there? So again, the building blocks of what's there. And behavioral diagrams show how things change over time with the behavior that goes on. And then an interaction diagram is actually a type of behavioral diagram and shows how messages collaborate with each other within the structure that you've set up. So the structural, behavioral, and interaction diagrams. And we're really going to focus on just structural and behavioral. And again, if you look at that, all the different UML diagrams chart, then you can see that the structural, we're going to look at object and class, and behavioral, we'll look at use case diagrams. So let's talk about some terminology when it comes to unified modeling language, when it comes to object-oriented analysis. So one of the goals in our Systems Analysis and Design class is to teach you some of the terminology of the unified modeling language. And one of the key, one of the first things we need to understand, one, we're talking about object-oriented, and we're going to go into some objects here in a second. One of the first things you need to understand is generalization and specialization. Now let's take a look at our different UML diagrams chart again. And you can see, if you look a little more closely, just look at that box right at the top in the middle that says diagram. And underneath you can see there's an arrow there, and the arrow points upwards into the diagram. If you go to the left, you have structural diagram as a box. And now you can see that the arrow goes from structural diagram up to diagram. If you look up and say the arrow goes from behavioral diagram up to diagram. So what's going on here? This is called generalization and specialization. And on pictures in UML, what we do is we arrow from a more specialized level up to a generalized level. And so that's why the arrow goes from structural diagram and behavioral diagram up to diagram. And then as you can see, we have we look on the left-hand side, we have object diagrams and class diagrams. Those are specialized types of structural diagrams. And if we look on the right, we have use case diagram. And you can see the arrow goes up to behavioral diagram. So the use case diagram is a specialized type of the more generalized behavioral diagram. And so that's just some terminology, specialization and generalization, that you do need to understand. Now, when we're talking about object-oriented analysis, it seems that one of the very first things we should understand is objects. And so we have this chart here that does this. What I love about this chart is it's got public parts and private parts. So what's going on here? Well, let's take a look at this. This is how an object is always drawn. It's drawn as a box divided into three, and at the top you have the object name. And the object, remember, is something, well, it's an object actually. It's something that needs to get done, and it's probably a good idea to look at the example here because it explains things well. And so the class or the object here is customer. So a customer is an object in the way we look at things in object-oriented programming and analysis. So the object, though, going back to that top box there with the three parts to it, there's an object, there's attributes, and there's processes. And so there's the object name, customer, and then customers have attributes that allow us to distinguish between the different customers. So let's look down on the left-hand side at the public parts of this object called customer. And we can see the customer has a phone number, a name, an address, and credit rating. And you can imagine that with a name and phone number and address, you've pretty nailed down each individual customer. Even down within a family, as you can imagine, if we have the name, phone number, and address, then we're going to be able to really pick out individual customers. And then what these objects do in unified modeling language, object-oriented analysis, they have processes, things that can be done to them. And so this particular object about customers, we can add, update, and delete. So what that means is, and that's, I'm looking in the bottom processes area, on the left-hand side, that bottom box on the left-hand side under public parts, I see processes, add, update, delete. And what that means is this object that we're creating for a customer, we're going to be able to add new customers, update, maybe name changes, change their address, change their phone number, and we're going to be able to delete customers. And we can see that makes perfect sense for a customer. Then there's also private parts. Now, private parts, when it comes to customers, need to be a little careful about it, but when it comes to object-oriented analysis, basically this kind of gets down into the detail. And much of the detail you don't need on an everyday basis if you're interacting with the system or even analyzing and designing the system. But you do need these private things to go on to get things done. So let's take a look. So for this object called customer, phone number. And so as you can kind of see here, and I'm looking a little more closely, we need to kind of specify that that's 3, then 3, and then 4, certainly for US phone numbers. We need that for the database. We need that from the program, and we need that for some error checking on entry. But on a day in, day out basis, we don't need that, and that's why it's a private part. You can kind of see that it says name, and we've given, it looks like 30 characters for that. Address, we have 60 characters for that. And that's what the X and then in parentheses 30 and 60 is. It's telling us how many characters we've set aside to get this done. And remember, there are some choices around that. You know, name, is 30 enough? Can think about whether that would be. And then on the processing side of things, you can see this when you add, so the process of adding, what do? Set all values to the defaults. So we want to just probably wipe everything out when we're adding a new customer first. And then get data and edit, check the customer ID. So there's a few things that we need to get done, or we'll have some processing behind it. So that's an object in object-oriented systems analysis and design. So here we have the definition of an object. And an object is any useful item that has identity, structure, and behavior. I think it's useful to have that word useful in there. So the whole point behind object-oriented systems analysis and design is that it's it has some flexibility to it. Useful is a perfect word, actually. It does mean that you should break things up into useful components. And so as it says here, when an object-oriented software system, so one that's built using an object-oriented language, when it's up and running, then it interacts with these objects, which is kind of how things happen in the real world. So we can imagine that customer object that we had before, that obviously interacts in the real world with the system and with pieces of the system, with things that come out of the system. Now, classes are a way to group together objects. You could talk about the generalization, the specialization that we had earlier. And so the generalization of an object is up to class. The specialization of a class is down to object. Or a class is a family of objects that have the kind of same template. The way I like to look at this is a class is a template for things that happen below it. And so let's take a look at this classes and objects picture. We have the object up top, and then we have classes at the bottom. And so we have customer, that's an object. They have a customer phone number, and there was, you remember, the add, delete, and edit was the processors. Now those are not shown in the bottom box at the top left there for customer, the object customer. Then you can see we've got classes. This video on rental. This picture here is an example from a video rental store. Of course, there's not too many of those anymore. But you can imagine this might happen indeed inside Redbox. So you can imagine this is how Redbox was programmed on the inside. But there's video on rentals. And that's just, if you can imagine, that's the class. Then the objects would be the actual videos themselves underneath this. And videos on rental, as you can imagine, they go out. So if we're looking at the bottom left box there, we've got video on rental. Goes out to a customer. How do we identify that customer? By their phone number. There's a barcode. We need to get it back on a certain date, and there may be some late fees due if that comes back late to us. And so that's an object under which we'll have a bunch of videos out on rental, which are the objects themselves. So that's classes versus objects. It becomes a little more clear as you do a little more of this. And so the next picture that we have here shows a class for bank accounts. So now we've moved into a banking environment. And you can see that this is the template for bank accounts. And what do we need for our template to work well, to define an object or a set of objects? Well, we need an owner. And you can see it says owner and then string. That word string means that it's going to be a bunch of letters, text, and maybe numbers as well. You can see then it says balance, and that's measured in dollars, and it's set the default is to 0. So you can default things, which is kind of nice. And then we've got some actions. Remember the processes on the bottom? Things we can do with a bank account. Well, what are some things we can do with a bank account? Well, we can deposit money and we can withdraw money. And there's plenty of other things as well, but this is a simple example. So this is a nice class which would drill down to an account object, and it shows the elements of a class. So the object-oriented modeling approach has a bunch of benefits to it, which are kind of listed on this slide. The ability to tackle more challenging problem domains. I don't know whether that's true or not. If you've been trained well in a particular way of getting this done, and you are good at interacting with users, then I don't know whether a more challenging domain demands an object-oriented approach. So I don't know if that's fair or not. I think the better way to put it is you don't have to be quite as good at what you're doing to tackle a more problematic domain with an object-oriented modeling approach. Because a lot of the complexity is hidden in those private parts that we had. And so I think that's what's really, maybe this is what this is getting to. It's that ability to keep things simple and hide the complexity, which then leads, as it says here, to improved communication between the users, analysts, designers, and programmers. And that would make perfect sense. If you're hiding the complexity, that obviously makes it easier to talk to people. But then when you get down to the programming level, you can open up those private parts, and programmers can talk to programmers, and the analysts can talk to the programmers. So I think this unified modeling language and object-oriented approach really does a great job of that. It allows, as it says here, reusability of analysis, design, and programming results. Yes, once we've defined a customer as an object, then we can just use the object over and over again. So that actually is a really nice feature of it. And that, as it says here in number 4, leads to consistency. If we've got nice, clear, simple ways to define things, that nearly always will lead to consistency. So let's talk about the development life cycle. Remember, there was 4 phases to the development life cycle, the software development life cycle, SDLC. And we decided we were going to use the Unified Modeling Language to get that done. So again, what is Unified Modeling Language? It's a notation that allows the modeler to specify, visualize, and construct pieces of the system to get things done. And there's going to be some techniques and techniques and notations. And the 2 that we are going to cover and work on in depth are use case diagrams and class diagrams. And as it says on this slide, there are state, there are sequence. Those are a little more complex. And my version of getting things done well is if you can understand the basics, then you've gotten 80% of the way there. And if you can do 80% of the job really well, then you can learn the other 20% later. So that's my job here, is I'm going to teach you 80% of what needs to get done. And that's use cases and class diagrams. So let's move on to use cases. Okay, now we're getting down into the nitty-gritty of systems analysis and design. And we're talking about use case modeling. Now, there's a bunch of definitions here. So a use case is a complete sequence of related actions initiated by an actor. And an actor is an external entity that interacts with the system. Now, that could sound complex. So let's break that down. An actor is someone who uses the system. Now, it also could be another system, but I think it's often very easy to think about an actor being a user. And then a use case is something the user wants to get done with the system. It's a case of how you will use it. And there may be many different cases or ways you want to do that. So what we have on this slide is a use case diagram for a registration system for a university. And it's just done, this has been done in Visio, and there's many different products out there. Microsoft Visio is a pretty darn good one. For us in our class, you can do this by hand, and you can use pencil, eraser, but you do need to use a ruler, and I'd like you to do as good a job as you can. But at the end of the day, I'm not worried about the tech, the programming that you need to learn to get pictures like this done. I'm more interested in making sure we get the picture done. So what do we have here? Let's walk through this university registration system. And what we have on the outside, those stick figures, that's actually how an actor is drawn in Unified Modeling Language for real. And so you'll see this, if you go out to Toyota and do a use case systems analysis, you would do it exactly like this, and they would expect you to do it like this with stick figures. So who uses a university registration system? Well, a student does. The bursar's office. You got someone to help you over in the registrar's office. And then there's, instructors need to know who is going to be there to teach. So those are the actors. You can see that they have lines that come inside the university registration system. And these ovals are different systems, different things that need to get done within the university registration system. So what's nice about this use case diagram is this is the top level diagram, which just shows, hey, if I'm a student, what do I need to get done with the registration system? Well, let's take a look. What do we need to get done? We need to register for classes, and unfortunately, we need to bill you as well to be able to take those classes. And so as you can see, bottom left, there's an oval that said student billing. And who else deals with student billing? Well, the bursar's office. That's the entity on campus that's responsible for making sure that stuff gets paid for and students pay for things and the money gets to the right place. Your interaction with the bursar's office is shown just as one kind of stick figure here. But if you think about it, that could be financial aid, and there may be different people inside financial aid that help you at different parts of the process. You may need to pay a bill. That's all captured just in that one stick figure for bursar's office. which is kind of nice. It reduces the complexity as you're thinking about this. And that class registration system, that oval that's at the top in the middle there, we don't need to know all the details just yet of how things get done, but we do need to know that a student is going to register for a class. And as you can see here, it's a student and there's a one-to-one. Those ones mean one student registers for one class at a time. Most systems don't allow you to register. Say we have Introduction to Management Information Systems, and we have 4 sections for it. We don't let you register for 2 sections. We're going to let you register for 1. So that's what that one is. One student gets to register for 1 class at a time. And again, this reduces the complexity of how we look at this. We don't need to know how many classes you're going to register for right now. We don't need to know which year this is for, which semester this is for, which major you're in. All that is going to be captured a little later. This just shows that we need students to register for class. On the right-hand side, we have a registration clerk that's going to help get that done. They're the ones who maybe set up the system, make sure we have 4 sections for Intro to Management Information Systems. What are the prereqs for that? How do we check the prereqs? The clerk may be the one who sets it up and, checks that or notifies a student when a prereq's not being met. Maybe the system does that. Again, the complexity is hidden inside these ovals and inside these actors, these stick figures. Then instructor, bottom right, that's me. What do I need to do with the registration system? Well, I may need to set up some special classes. It could be that every year I teach the same classes, everything. The system just handles that. We roll it forward. What if I've got a special class, a weekend MBA class that I want to teach? And I'm going to need to tell the university registration system to set that up. So that's a really nice high-level version of a use case diagram showing the actors and the system and how they interact with each other just at a very high level. So as we can see on this slide, it's kind of just a bit of a summary of what I just talked about. But use case modeling. A use case is always initiated by an actor. It represents the complete functionality of the system. Everything your system that you're analyzing and designing, everything is put in there at a high level. Use cases, so this registration system, as it say, may participate in relationships with other cases. Well, of course that's going to be true. If you have students on campus, they don't just register for classes. So there's going to be other systems out there that this use case interacts with. As an instructor, I don't just add special classes. There's other things and other systems that I'm going to do. Use cases may also use other use cases. Well, that makes perfect sense as well. This registration system is going to interact with the billing system. It's going to interact with our learning management system, which we, of course, use Moodle. So all those systems interact with each other. But again, this is just a way to get this done at a nice, high, understandable level. So a little earlier, we talked about object diagrams and class diagrams. And what I said was that a class diagram was the high-level generalization of the object diagrams. And so this picture maybe will help us a little bit. Up here at the top, we have a class diagram showing 2 classes, and that's the student and courses. And on the left-hand side, as we draw things out, you can see we have the standard 3 boxes. We have the name, attributes, and processes for the student. So this class diagram for this class diagram right here is called student. The attributes that go along with a student, the things that we need to identify a student, are name, date of birth, year, address, and phone number. And then what sort of things, processes may we want to do with a student. We might want to calculate their age, not sure why. Might want to calculate their GPA, of course, and we may want to allow them to register for courses. So that's a great example of a class diagram for a student. And then we'll go down to the bottom left here. Then we have an object, a particular student. So this particular student is Mary Jones. That's the name. And then you can see under the attributes, name equals Mary Jones, date of birth equals 4/15/1978, year equals junior. That's the object that goes along with the class student. And on the right-hand side, you can see we have course, top right, course. There's a class name, then there's the attributes, and then there's the operations or processes. So the course is called core, when we're looking at courses, we call them courses. So that's the name we're going to use. How do we define a course? Well, we have a course code for it. We have a course title, and we have how many credit hours. So BMIS 373, Systems Analysis and Design, 3 credit hours. And then we need some operations or processes that go with that course, and that might be the number of enrollments. 35 students is the number of enrollments. That's a class diagram. It's the generalized form of things, but then we have specific classes. So as we drill down the bottom right here, then we have a course. This particular object is for database management, MIS 385, 3 credit hours. So hopefully that explains a little bit better the class and the object diagrams. And what we're doing here is we're encapsulating, we're hiding the complexity inside these boxes. So if you take another look at this student, it says calculate the age. We don't need to know how to do that. We just need to know the outcome. Obviously, there's going to be some logic, some processing behind that. Current date minus date of birth, with some sort of function to make sure this is in years and not days, equals the age. GPA, how does that get calculated? It's the credit hours, the grades you got, all weighted up. So, but we don't need to know that. We just have it that as calc GPA. So that's called encapsulation. It's where we hide the details of the processing behind some simple words in the operations part of the class or object. That is a really neat way to get things done. So as you can imagine, really, things never stand alone. And so we've got these classes, these courses, we've got students. They kind of go together. They're associated is the word. And association is the term that we have for the relationships between objects and classes. And there's different types of association that you can have. There's unary, binary, ternary, or higher. I think you would figure that one out. Unary is 1-to-1, binary is 2, and ternary is 3, and higher is more than that. And we have them as a line. Best way to look at this is, and the quickest way to learn this is just to see an example. And so here we have, it's figure A.4a. We have a person apparently is only married to 0 to 1 people. So that's 0 to 1 there. So I'm looking top left, person. There's kind of a box that goes around to another person. So you can have 0 people married to 0 people. But you can have 1 person married to no one. Or you can have 1 person married to 1 person. So this is the traditional definition of marriage, by the way, here. So that's 1 person being married to 1 person. Look at the top left, we have employees, and you can see there's a star there, and that star means could take any number. So any number of employees is managed, and you can see that's what that little managed says, by 0 to 1 managers. And even that may not be true, there may be more than 1 manager, but typically a manager will have 0 to many employees, and employees will have 0 to 1 manager. So let's look at the bottom left here. These are the binary relationship, and so you can see employee 0 to 1 is assigned to 0 to 1 parking places. So I guess you only get to park in 1 spot. A product line, 1 product line contain 1 ... star, that ... star. So a product line has to have a product in it, otherwise it's just nothing. But it can have many products in it. So that's a 1-to-many relationship. And then you have student star. You can see the little star that's very tiny. Registers for star courses. This is a many-to-many relationship. What that means is student between 0 and many can register for between 0 and many courses. So there are students who register for nothing, and there are students who register for many, and there are courses that get 0 students, should be cancelled, and there are courses that get courses that get many students registered for them. And then bottom right here we have a ternary relationship. And so a vendor can supply parts, and it gets the parts from the warehouse, and the parts also get stored in the warehouse. So a vendor, and that little star shows that there are many parts, and those many parts may go in many warehouses. A warehouse has many parts that come from many vendors. And so those are the different associations between classes. Now, we've already talked about generalization before and specialization, and we need to talk about it again because it's a really important feature of kind of what makes object-oriented analysis so powerful. So generalization is where you bring multiple classes together because they all look the same. As it says here, a subclass is a class that has been generalized. A superclass is a class that is composed of several generalized subclasses. Best way to do this is to look at a picture. I always find pictures really help to explain a lot of what's going on here. So what do we have here? This is a class diagram. All right, so middle top, we have a class called employee. Now remember, we could have an object for a particular employee, Dr. David Firth, University of Montana. But the class is the higher level version that contains many employees. So what is that? 1,500 faculty at the University of Montana. And so this particular class could have 1,500, will have 1,500 objects in it, each of them a faculty member. So there's an employee. We've got the attributes, our name, number, address, the date we were hired. And wow, look at what we get to do. The processes we get to do are print labels, which is pretty much explains everything in our entire employment worth at the University of Montana is our ability to print labels. But as you can see down here, there are three subclasses of these employees: hourly, salaried, and consultant. And you can see why they would be able to do different things and get different, these are different employment types. So the hourly employee, they're going to have an hourly rate. The salaried employee will have a salary, and the consultant will have a contract billing rate. So different things. But again, let's just call, at an early stage in the process, we can call them all employees. Think about some attributes, what we're going to allow them to do. And then when we get more into the process, we can drill down into these subclasses. While we're at it, that employee, the generalized version is called a superclass. The hourly, salaried, and consultant, those are called subclasses. You've got super and sub. Generalized, specialized. So there you go. Aggregation is something that has several pieces to it. And again, let's just look at the example. So we have a personal computer here. Let's call it a laptop. It's going to have a CPU, a hard disk, a monitor, and a keyboard. And this picture here shows aggregation of the CPUs. The 1 to 4 shows that this particular configuration can have between 1 to 4 CPUs. 1 to many hard disks, 1 monitor, 1 keyboard, 1 partridge in a pear tree. But this is, that little diamond shows that you don't get a personal computer without those pieces put together. So that's an example of aggregation. So one of the beautiful things about the Unified Modeling Language, and when we do object-oriented systems analysis and design, is this notion that we can take an object and we can look at it, we can look at the use case for it, and then we can also take that object through a process and show the different states, the different ways it looks as it goes through that process. Those are done using state diagrams. Now, we are not going to do a state diagram for our project using App Inventor. Usually that's because there's just not that many states, to be honest. Also, it's a little more complex to get our heads around. But nonetheless, let's make sure at least we know what a state diagram is and how it works. So state is a condition during the life of an object during which it satisfies some conditions. So you've got to be able to define its state. It may perform some actions, or it may wait for something else to happen. And it's shown as a rectangle with rounded corners. Let's take a look at the diagram. Again, when it comes to object-oriented systems analysis and design. It just helps to look at the pictures. So this picture here is a state diagram for a student object. Okay, so we've got this student, could be a student class. Notice, by the way, that there's a bit of you'll notice in this when you're out in the real world. People use object and classes a little bit interchangeably. This really should say student class if you ask me, but nonetheless, let's not worry about that too much. All right, so you got a student, they inquire, and now they're in the inquiry phase. And that needs to have the current date is greater than the school begin date. Oh, I guess you can't apply once school started in this particular process. So you make an inquiry, then you submit an application, and then you now become an applied student. And then, of course, once you've applied, there's going to be some sort of process around whether to accept you or not. And so as you go along the top of this diagram moving right, you know, if you're not acceptable, then we're going to mail you a rejection letter and you become a rejected. Your state becomes rejected, which will probably put you in a state as well. Or you can apply, and then down the middle here, the arrow down goes to approved. Yay, you got accepted to college. And now that's another state. Now you're in the approved state. And of course, there's a couple of things that can happen once you receive your after you've made an inquiry, applied, and been approved to come to college, you get a choice. You can say, no, I don't want to go there, and that will take you right, and now you become a withdrawn student. You are withdrawn from the process. Or you can go off to the left here. It's where you say, yes, I'd love to come to the University of Montana. You accept your admission. That takes you down to confirm. You can see that you can, at this point, you can, if you did withdraw because you were crazy to decline your acceptance to the University of Montana, you can actually withdraw your withdrawal. You can reaccept. So that's what those diagonal arrows are doing. And then once you confirm, then you get on campus. We matriculate you, put you in the system, give you a tour of the dorms, put you in a dorm and all that good stuff. And then I love this. You go straight from the matriculated. 4 years later, you graduated. Or you drop out, which we try and avoid if at all possible. But again, isn't that just brilliant? It's kind of all the states that a student can be, or a lot of the states actually, not all of them, for a student as they go through from being a high school junior or senior to being graduated from college, all shown in one picture. Imagine all the complexity that goes under that. But again, this state diagram allows us to think about the whole process in a very simple fashion. So let's talk about another type of unified modeling language diagram, and it's called a sequence diagram. And a sequence diagram depicts the interaction between objects as time goes by. Sometimes these are called swim lane diagrams, and that's because they look like they have swim lanes in a swimming pool. Again, quickest way to get this done is to look at a picture. So let's look at this sequence diagram for class registration for classes that have prereqs. And so let's start top left. And this is an object, right? It's a square box. It's got those double dots. It's called registration window. So we've opened up a registration window in our system. And what do we do next? What do we do next? Well, this blue line going straight down is the swim lane. It means the registration window is open. But you're going to do some stuff with that registration window. So the next swim lane over to the right is we're going to enter a register a registration entry. And basically what it says, you can see these little arrows, it's the information we need to get things done. So we open a window and then we enter the class. So we need to go and look at a class to see if we can register for it. So we need to open the class, which has the object for classes. And that's not great that this was a class registration system since we're talking about classes and object. So let's maybe use some names. So we're going to open a class, maybe in the MIS major, and the particular class we're going to look at will be Systems Analysis and Design, BMIS 373. So first we need to check, is it open? How do we need to do that? Well, we need to go to the objects and classes. So there's a class and then the object, is the course open? So we'll take a quick look. We'll go and grab the course, go and grab the student. So for that course, is it open? That's the middle of the 5 lines, 6 swim lanes, I guess. Check it's open. If it's open, go and check on what the prerequisites are. And you need to do that by looking at the course. Remember, it was our registration clerk that entered those. So check what the prereqs are, and for 373, I think that's just you'll have to complete the lower core. Assuming that you have those, then you need to go and check that the student has the correct prereqs. Assuming those are true, then assuming if the course is open, we know what the prereqs are, that the student has them, then we can enter you in the class. Maybe the class is full, so now we need to check if the class is full. If it's not full, then we can enter you and you are added as a new student. So that's called a sequence diagram. It lays out the sequences of all the pieces, all the different objects that your system needs to interact with to get a student registered in class. So what we're going to have you do next is we're going to have you draw out a class diagram. So this slide shows you, gives you the details of what you need to look at for the class diagram. So here's what I want you to do. Take out a paper, pencil, or a paper and pen if you wish. Read through this, draw out what you think the class diagram looks like. And as you can see, it's for several chemists. They work on projects and they need equipment. And they have assignments. So you can already tell that I'll give you a little hint here. There's going to be 4 classes or objects. You can have chemist, equipment, project, and assignments. Pause the video right now, do this, and then look at the answer here in a minute. Okay, so this is the answer. And as you can see from this, we have 4 objects or classes. These would actually be called classes. Top one in the middle there is chemist. Now remember, these are the classes. The particular object might be chemist, you know, Dr. John Smith, Dr. Mary Jones, that sort of thing. Anyway, chemist is the name. We need a name and phone number to make sure we know exactly which chemist we're talking about. And they have the average amount of hours that they need to use the equipment. So they're borrowing equipment for experiments. And that little star shows that there's many chemists getting this done. Off to the left, we have projects. And again, this is a class. When it comes down to the object, it might be project, I don't know, 1, project 2, project 3, project Salamander, project China, project Asia. Then there's a project name. It has a start date, 1. ... star. That means there's one to many projects going on. So there's always something's always going on here. Otherwise, we'd have people just sat around, which would be crazy. Equipment on the right-hand side. Again, 1 ... star shows there's one to many pieces of equipment. The name for the equipment is equipment. This is a class diagram right here. Serial number, cost, and type shows that allows us to know exactly which piece of equipment we've got. And then the chemist, project, and equipment, they're all assigned to a particular assignment, which has date and total hours, so we can track what's going on for a chemist on a project. Because remember, a chemist could be on more than one project. So a chemist may have an assignment to one project, an assignment to another project. So there you go. That's a nice in-class exercise for a class diagram. So at this point, I want to help you out when it comes to your system to think about what a class is and what an object is. And what I find really interesting is the technique we use to get this done is called underlining the nouns. Really, that's what it's called. And as it says here in parentheses, and the words that relate to nouns. So this is a for real way of getting things done, a business process here. Step 1, though, is you need to describe your system. You need to write out what your system does. User presses this, launches the app. The app comes on, there's this screen. Then the user does this. Then the programming behind the scenes does that, gives this for the user, goes and grabs that. Weather app, it may be first user powers the app up. First screen launches. First thing the system does might be to go and find what the GPS location is of the phone at that time. Then once it's got that, it can go with that zip code to go and find, from weather.com, what the weather is for that particular location. Then it may display that on the screen. Well, maybe the user's traveling. That's why they pulled up the weather. They kind of know what the weather is where they are, but they're traveling. And now they need to be able to enter a zip code. So what do you want to do next, user? Do you want to just look at this? Do you want the 5-day forecast for a current location? Or do you want the forecast for a different location? So there's going to be different things that you present to the user. Anyway, you write all of that out, and then you look at each noun in the description and check to see whether it does this. Is it a thing or a family of things? If it's a family of things, then it's more of a class. If it's just a thing, it's more of an object. Is it part of a problem to be solved? Is it not part of the implementation details, because we're going to hide those away? Is it not an event or occurrence? If it's an event, then it's not a class or an object. A class or an object's a thing. It's not an event or occurrence. It's not a property of a thing, because obviously that goes inside our class and object diagrams. So that's how you figure out classes and objects. Step 1, though, got to write all this out for what your system's going to do. And that's called the summary paragraph. And so you need to describe the system. And in Moodle, I've put 3 examples of how to get that done. So this summary, and just so we're clear, this summary paragraph is actually really quite difficult to do. And so what I've done is I've posted in Moodle a case study document, how to develop the summary paragraph, and then how to identify classes and objects. And what's really nice, and this is a free book from Conga, Sue Conga, is you kind of got the overview of how the system kind of operates, and then how you would go ahead and develop that summary paragraph, and then from that how you would identify the classes and objects. Really nice documentation, and you really should make sure you go ahead and do that. And then what I've put next is I've got a slide on kind of how to figure out objects and classes. Because once you've underlined all the nouns, then you need to decide what you're going to do. And so this slide here kind of helps you figure out what's going on, and it goes through that checklist that we had. Is it a family? Is it a proper noun? Is it a value? Is it a condition? Is it an occurrence? And so this slide really does a nice job of explaining that. And then this final slide here just kind of helps you name your classes. And naming classes, I'm really not too worried about how you do this. It wouldn't matter to me if you had My Modern Crash Dummies or just Crash Dummy. But really, you need to have, this slide just gives you a bunch of the rules that need to get you down to your class diagram, your class names. And as you can see, they're just really focused. Is basically what's going on. So not singular, it's singular, not plural, isn't possessive, uses capital letters, doesn't have spaces. So there's just a bunch of little rules, and this slide gives you the rules. So follow these rules to get your class diagrams. And that is it for our Systems Analysis and Design Object-Oriented Analysis class.